Welcome everyone. This is video number 5 in a series based on my book Learn Harmony v3 for PIC32MZ. Video number 1 showed how to set up a development environment for programming PIC32MZ devices. Video number 2 showed how to configure the Curiosity 2.0 PIC-MZ-EF development board, configure the basic Harmony software components, compile, load, and execute the application without creating any custom code. Video number 3 explained the super loop and how to add multiple state machines to a Harmony project. Video number 4 added custom code that used hardware timers and a new state machine to control the LEDs and switches on the development board. In this video number 5, I will show you how to add the USB library to the project and use the Communications Device Class, CDC, function to add 2 COM ports to the project. As a reminder, all of the custom source code used in these videos is available from GitHub. On the screen is the instructions on where to get that and how to download it. If you haven't done it before, you'll have to do it now if you want to actually follow along with any of the code. Before we continue, I want to give you some information about the USB library that is included with Harmony. You'll see on this diagram that there's some lower level device controllers, device layer that is created or controlled by Harmony. Then there are some function drivers in the middle, and we're going to be using CDC 1 and 2 to control 2 serial ports. The USB library also has an HID option function and the MSD, which is for host. HID is for keyboards and mouse and that sort of thing. And then there's all your custom code up here in the user application. Okay, let's look at all the tools and techniques we'll use in this video. We're going to add the USB library to the available software components first. And remember, this goes into the general library, not the project itself. We're then going to show you how to clone the MZEF base project that we created in video number 4, because this is a way to fork the project so you can start trying new stuff and still get back to a known point. Then we're going to add the USB CDC function library to the project and configure it for 2 COM ports. Okay, let's get started. First we need to open the project that we finished in video 4. So we have a starting point, the MZEF base. Let's get that right. And now we'll go up here to Tools, Embedded, Content Manager. We're going to go get the USB library. So now, connecting to the GitHub repository for all these packages. Now, they probably, since the last time we've done this, there will be some indications that things have changed, so we have to address that before we download the USB library. And yes, there it is. MHC has an update. So let's go find that. And so MHC is a local package. And there it is. And look, there's 2 others that have to be updated. So it says we should do this one first. So do that. That was fast. Do this one. And this one. Okay, now our local packages are correct. Now let's go back and pick up the USB library. Let's go find it. Fix. There we are, USB. Download that. And it says it'll automatically add the board support package, which we don't use, so cancel that. Now we just have to accept the licenses. And the download is starting. Okay, the download's complete. Go over to local packages to make sure it's there. Right, and there it is. Download USB. Everything is synchronized. So close this. All right. Now what we have to do is clone the MZEF base project to change its name. So let's go into Finder, microchip, V3 apps, and there's MZEF base. And so what we're going to do is copy that. So I'll duplicate that one. And let's change the name of that to MZEF CDC. Go up here and close this project. And open a new one, open a new project. The apps, and there's MZEF CDC, firmware. We open it, we have to find the .x file. So its name is still MZEF base, so right click on that, and under rename, change that to MZEF CDC, rename the project folder, go with rename. And we set this as the main project. Okay, I think that is everything. You'll notice now the project name has been changed, but all of the configurations and everything is the same. You still got the PIC32 compiler data. We still have the starter kit. Everything is the same as it was before. And if you want to just verify that everything is still working, let's clean and build it because it's so fast. So we cleaned out any reference to MZEF base. Let it create a new application file executable based on the same configuration parameters. Build successful. Okay, so we haven't messed up anything, and so from now on, any problems we run into are going to be new to this project. Now we want to add the USB library to this project. Tools, Embedded, Harmony 3 Configurator. I'll launch that. And what's in here is not compatible with the project's stuff that we just downloaded. Oh, local. See, we had 3.11 before, we just downloaded 3.12. In that previous screen, if you're in the middle of a project and don't want to mess with the new downloads, it allows you to continue with the ones you started with, but I think you have to go back and back up to the previous versions. That's what that manifest message is about. So we want to make sure everything is up to date, so we're just continuing with the latest versions, I hope. Okay. Okay, to start after we've just downloaded the USB library, it's to see where it ended up, at least for now. Let's go back here to Applications V3, Harmony V3, and there's our two projects. We cloned the base project into a CDC, and here at the bottom you see USB is shown up. Okay, so it's in our local packages, and it shows up here on our project, under libraries, USB. So let's add the CDC library, CDC function driver, double click that. Then it brings in the USB layers that we saw in the diagram. It also brings in the time component, which we will need. And that's what shows up on the project graph now. So notice time has a red connector. It needs to be hooked to something. So we're going to hook it to core timer. Double click that. Over here and connect the two. And there. We're also going to need two instances of the function driver, so we're going to add one right there. Okay, so that will be the two ports, and we'll rearrange these appropriately. And now we're ready to configure all these new components. Okay, now that we've got all the new components in there, let's configure them. One at a time here. Core timer, interrupt mode, yes, that looks good. Time, use the core timer, tickless, yes. Need the high-speed device, yes. Device layer, two endpoints, special events, nothing there. special features. Okay, we need to enter the product ID. Let's move this over a little bit. And we're doing the CDC COM port dual. Self-powered maximum. Okay, that looks good. Function driver, do instance 0. And 0, 2, yes. 1, 1, 2, 2, that looks good. Good, instant 1. That's 2, 2. Starts at interface number 2 and goes up to 4. Okay, that's standard, that looks good. And let's configure it. Do the code. Generate it. And do the output. And there we are. Load, build successful. Load complete. Okay, we're ready to add a state machine to handle the USB CDC function. So first what we have to do is create a header file. PIC32, call it CDC. And that gets created. And now we'll select everything and delete it. So we've got a clean file. Do the same for the source file. Create a new source file. Name it CDC. Oops. Select all. Delete it. Now we have 2 blank files that we'll fill in from our learn HV3 figures.txt. So first one we'll do is the header file. So we'll just copy all of this down to the end. Control-C, Control-V, all is, and we go CDC, over to the text file again, and this time we're going to copy all the source code, quite a bit of it. Okay, down to there. Okay. C, V, and we have all of that. Now we have to go and clean up some of the app files. Let's go to app H, and we have to add the new header file, and that's called CDC, and in app H we have to add the initialize, call to the initialize. Just duplicate that. Call that CDC initialize. And this one we're going to have to add a state machine call. CDC Okay, we've got all the source code in, so let's just go ahead and clean and build the project to be sure that all of it is still okay. And then we'll download it to the board and test it. Quick test. This isn't very comprehensive, but it shows that it all works. Okay, build successful. So now let's use the green down arrow to recompile it and load it onto the board. So, and boom, it's complete. Now let's already configured a CoolTerm session for both COM ports. It's explained more in the book, but it doesn't have to be CoolTerm. It can be any serial port device, and probably would be on a different machine. But for now, we'll just use our own machine. So we have two ports, one for the log messages and one for the console port. So on CoolTerm, you have to it identifies the ports that we're dealing with here. This is done internally, so do that OK. And connected. And there are the two log messages that come out of the source code. If you can trace them back and see where they come from. So that shows that COM port's working. Let's go over here to the other one. This is the serial port, and this is on 201 port. Okay, and you'll notice there the baud rate and 8 stop is none and 1. That's all in the configuration in the source code that you can find. So we'll connect to that one. Okay, and this is like a console port, so there's a prompt, and it's echoing anything that you type in. Big deal. But this is the basis for if you were to write a console driver so that it would recognize specific commands and do something. So anyway, that's it. So it shows that both CDC COM ports work. So we'll disconnect those, and get rid of it. Okay, so a quick explanation of what's going on is let's look at the header files, show you some interesting places here. Under USB, there's two files, header files here, one USB device .h and USB device C. Let's bring that up. And here at the bottom, way down here, are some interesting explanations of the events that occur that the USB stack takes care of. And this is very interesting if you want to trace back some of the details in the code. This is where you would find some explanation of what that's doing. Same thing for the USB device CDC thing down here at the bottom, are the event function driver events that you can that are reported back up through the stack, so your source code can take advantage of it if you want. And you'll see that in the code if you look through it. So that's about it for this one. We've successfully made our CDC two serial port application. So what is our new state machine doing? it's providing an event handler for the USB device events and the USB CD function events. And it configures the USB port to handle two COM ports as serial CDC devices. And what we programmed in here, just for the example, is COM1 is just going to echo any character that is typed, and COM2 is going to send out any new log messages created by the application. Okay, at this point, we've forked the base project to include the USB library and to create two serial COM ports for communication with external devices programs. In the next video, I'll add the TCP library in a series of steps that show you how to configure and use all or parts of the TCP/IP library that's included with Harmony. So remember to hit the subscribe button. Thank you for watching, and I'll see you in video number 6.